Hey there, it's Jamie. And at the time of this recording, the date is February 5th, 2021. And one of the most important topics in the news right now is the rollout of the coronavirus vaccine. So I'm going to use it as this week's demonstration example. I'm going to use this time to make a visualization that shows how many doses of the vaccine have been distributed across the nation and what percentage of the population has received at least one dose. I'm also going to take a look to see how that varies by region. I also want to break this down a little bit further and look at how many people or what percentage of people have received two doses, which is how many you need to become immune from the virus. And then I want to break that down and look at it by state and population. So, like with any analysis, you want to start with a series of questions. And I've got 3 questions here. Just so you know, these aren't the 3 questions I started out with. I ended up with an analysis that I liked, and I came back and I revised my questions so that they fit what I had actually done. Because often when you start, the questions you begin with aren't the ones that really fit, or they aren't the ones that stick as your analysis progresses. So you often have to come back and revise your initial questions. So here are mine. How many doses of the coronavirus vaccine have been distributed in the United States? What percentage of the population has received at least one dose of the vaccine? And how is the proportion of the population receiving 2 doses varied by state and region? To answer these questions, I used 3 data sets. I had to use 3 because there wasn't a single data set that contained all the variables that I needed for my analysis. I took them each, uploaded them separately into Tableau, and then connected them together using relationships. So the first one I used, it contained most of the data I needed, was COVID-19 vaccinations in the US, created by the Centers for Disease Control and Prevention. It gave me information on the distribution and administration of vaccines, also by state. And then I wanted to figure out if states of different sizes were better or worse at giving the vaccine or getting the vaccine actually administered to people. So I needed a table that gave me the number of people who lived in each state by year. And for that, I used annual estimates of the resident population by year, and I got that data set from the US Census Bureau. Then, so that I could break the analysis down by region, which is important to have something like region as opposed to 50 states if you want to put data in a table, I needed something that told me which states belong to which region, and I got a data set on US Census Bureau divisions and divisions from GitHub. The links are available either below this video, or if you're a student, they're on your Canvas site, or if you have this website, if you have my slideshow, you can click on the links to get the data. This week, I want to introduce 4 new tools. 4 different ways to visualize data: text, tables, spatial analysis or maps, and scatterplots. So let's start with text. You might not think about it this way, but text is actually a type of visualization too, and it's acceptable to use text in your visualizations when you're conveying key pieces of information or high order information. Our brains get overwhelmed with text, so you want to use text sparingly. And here I'm using text to show the total number of COVID-19 vaccines distributed in the US as of today. And so we can see that that number, 56 million, is the total doses distributed. That's a big overarching number that guides my visualization, so I decided to use it as text. The second thing that we're going to look at is tables. Tables basically just add order to text by presenting them in a format that is easier for our minds to read. Small tables like this one can be included in a dashboard or live presentation, but I wouldn't generally go any larger unless I was distributing a table as a visualization that people would read. It takes a long time to sort through and really understand relationships in tables, so although they convey a lot of information, they're not really suitable if you're moving quickly or expect people to only spend a short amount of time looking at it. Tables have one advantage of tables is that they allow you to easily compare numbers that have very different units or magnitudes. If we look at this table that I've included here on regional vaccination rates, the South, the southern United States, has about 125 million people. That is what I would call a large number. However, the percentage of the population in the South that's received at least one dose of the vaccine is 8.71%. That's a very small number. It would be challenging to present such a large and such a small number together on almost any other kind of visualization. So what we can garner, or what we can learn from this table, is that the South is the most populous region by actually quite a bit. The Northeast, in contrast, has less than half of the number of people than is in the southern region. However, there's not a lot of variation with regards to the percent of the population that's received one dose of the vaccine. The West has the highest percentage that's got at least one vaccine with 9%, but the differences in the numbers between these regions is really small, and I'm not sure that it would be statistically significant. So let's move on to something that's maybe a little bit more fun, and that's spatial analysis. Spatial analysis helps us visualize data based on where it falls geographically. Variables can be a known region, such as something like state or country, or it can be entered and stored in Tableau as a latitude and longitude. Tableau can't make a map chart if the state name is stored as text. So when you're looking at your data, you want to look for the circle icon next to your variable name to make sure that it contains geographic data as opposed to just a word. And so to make this chart, I used a variable called state, territory, federal. And you can see by the little circle globe icon to the left of the word state, territorial, federal, that this data is stored in a form that Tableau can put into a map chart. So in this chart, darker shades indicate that a larger share of the population has been vaccinated to full immunity. That means they've received 2 doses of the vaccine. And just looking at it, I see that California, that's my state, it appears to be lagging behind much of the country. Alaska and the Dakotas and West Virginia have the darkest colors, suggesting that they're getting people vaccinated with both doses at a faster rate than the rest of us. We're going to take a look at one more type of chart that's the scatter plot. When analyzing data, we often need to know if 2 variables are related. Height and weight, for instance, or maybe the size of a house and the price that it sells for, or maybe the sugar content of a cereal and the total calories per serving. If both variables that we're interested in are continuous, or if they can assume a wide range of values, you can use scatter plots to better understand their relationship. This graph shows the percentage of the population that's received 2 doses of the coronavirus vaccine as of today, as a function of the state's population. So we can see that the trend line, which I've inserted here, is downward sloping. And that means that more populous states have been not quite as good at getting people vaccinated with both doses as have smaller states. The reason for that could be many, and I don't know at this stage what that reason is, but we can see that there definitely is a relationship between state size and the percent of the population who has received 2 doses. Scatter plots are usually one of the first things we do when doing linear regression. And if we're translating linear regression into Tableau, we take our independent variable, what we would normally put on the x-axis, and we'll put it in the column field. The dependent variable, which is our outcome variable that we place on the y-axis, goes in the row field. And that trend line can quantify the relationship using linear regression. If you need a refresher on linear regression, I suggest you read Amy Gallo's refresher on linear regression. If you're in my class, there's a link on Canvas. If not, a Google search will help you find it. All right, so just to wrap up, the type of visualization you'll need to answer your question is going to depend both on the data you have and the question you're trying to answer. But here are some guiding principles. You should start your analysis with simple, specific questions. You can edit those questions as you explore the data and uncover things that may be more interesting or more relevant than the first questions you began with. And then focus on telling the story as directly as possible. You can make a lot of visualizations, but showing a lot of visualizations doesn't actually make your story any more robust than it would be if you just chose a few really good visualizations. And always use the simplest visualization that you can to convey your message. If you're using a complex visual to convey your message, but that message can be conveyed better in a bar chart, use the bar chart, even if it's not quite as fun. And then always end by summing it up, right? Answer your question, what did I find? And we did that in this analysis by talking about how larger states are not rolling out the vaccine quite as good as smaller states. All right. Thank you for watching this video, and you can follow up with how to make each of those visualizations that I shared in this mini lecture. And there will be one more video for each of those methods. Happy watching.